Hello, and welcome to the second podcast of this channel. This time I had the pleasure to chat with Albin Carlson. Albin is a recent architecture school graduate and a co-founder of Polymorph, a company that is oriented towards digital design and fabrication. What I find very interesting in his work is that he merges the workflows of Houdini and Grasshopper to produce bespoke 3D printed clay designs. So it's not plastic. This is something that we've touched upon quite a bit, and Albin has showcased quite a bit during this podcast. So don't turn away from your monitors just yet. There's going to be some nice stuff there. Hope you will enjoy this one, and let's begin. So yeah, thanks again, Albin, for doing this.
Thank you.
How long did it take? It took for us like four months to do this.
Yeah, something like that.
Been busy, huh?
Yeah, we haven't been swamped, but having things to do constantly at least.
Mm-hmm.
So not super stressful, but still things to do. So busy in a way, I guess.
Yeah. Well, you did have that exhibition that we were talking about just before I started recording.
Mm.
Tell me about that. Right? Tell me about what you did, and also just in general, what's your training? What kind of what do you do? What are you? Who are you?
So I guess the exhibition started out. We exhibited several structures basically. So I think we exhibited. Hang on. 5 structures. 5 structures made from 3D printed ceramic bricks, basically. So 3 of those were 6 structures, and 3 of those were actually from our thesis project. Me and my colleague. She's also my girlfriend.
I saw you stutter there. Me and my which one to choose?
I don't know which one to choose. Jumping straight to girlfriend might sound a little bit strange, but also colleague.
Why not both? Why not
exactly. Both? So 3 of those structures were actually made as a part of our thesis project.
Mm-hmm.
And then we sort of continued working together on that project and several other ones as well. Just continuing to developing these 3D printed ceramic structures and the brick that they're made of. And we just bought a ceramic 3D printer and ran with it, pretty much. That's what we've been doing for about a year now. Yeah.
Lutum, huh? Will you show Lutum at any point in time during this podcast, or do you have any kind of videos of it? Or? Yeah, I mean, any videos of it or anything like that.
Yeah, I might have a Vimeo video up of it printing something. Cool. Actually,
yeah, then that would be just cool to see, how it actually works. Because we are used to, plastic printers. Those are, at this point, they're kind of boring, just your regular approaches. But clay printing, it's getting quite a bit of traction, at least in the field of architecture. But, or I shouldn't say field of architecture, in the field of ex-architecture students. Students who finish Lund tend to do clay printing, apparently.
Yeah. Yeah, well, it's pretty. I find it pretty. I find it very cool that it's possible to do, real scale architectural objects on these machines.
Well, yeah, and we should. Sorry to barge in. We should probably also note that you are a trained architect, by trade. You have finished Lund University as an architecture student, And I believe, wait, I was your teacher at one point, or at least a teaching assistant in one of the courses, or
yeah,
no?
yeah. I think you were. I think you were my teacher in the Grasshopper course.
Oh yeah. So then I was like a super.
You were definitely a teacher in the Grasshopper course.
Yeah, I was the teacher assistant there. Not, far from a teacher. But now look at me. Anyway.
Yeah.
Okay, so you finished the school and now you're doing clay printing. Any plans to come back to do some research, to do some PhDs, something like that?
We're actually involved right now in a research project. It's a small research project, but a research project nevertheless. We haven't completely decided what it will be about. We know in what area we want to develop the 3D printed brick. We want to try some things, but we haven't really fully fleshed out sort of what we are going to do. It's quite still in early stages at this point, but it's a research project, and we will sort of.
Is it within academia?
Try to evolve this brick. Yeah, it's at Lund University. So
okay, that's cool.
Formally, it's so it's gonna be like one. Officially, it's 1 day a week. But we will sort of, when you start printing and when you work on things, you tend to spend maybe several days, consecutive days after each other doing something, because when you print, you don't want to just print for 1 day and then do something else. But as long as you have everything set up, so you can just continue going. I think it will be something like that will work maybe a couple of weeks and then do something else and work a couple of weeks at a later point.
Okay. And when you say us, when you use plural, it's you and your how do we? Let's say partner. You and your partner, right? Partner in crime.
It's me and Johanna, and it's also David, at the school. Yeah. So.
So you and Johanna have started like this company. It is a company, Polymorph, right? I guess we can jump into what you do in Polymorph and how you kind of. First of all, I always had this question in Polymorph, like in your company. Do you do any architectural work? Like we have
done we do actually in our company. We do building permits and things like that, which is just good money, a way of getting some money. It's not what we it's not what we do most of the time. Most of the time we do other projects, research and design related things with ceramic 3D printing mostly. But we still do some architectural projects. We also have done a few competitions, mostly idea competitions. Some of them pretty far out. But at least a few, architectural projects that we do. It's not something that we do all the time, but.
But yeah, it's always to have like a diverse income, right?
Yeah.
Not just to focus on one thing. But that's what I kind of noticed that about students these days. At least students who finish the university, like finish architecture education, who focus on these digital tools.
Sorry. Yeah, I hear you again.
Oh, I got disconnected for a bit.
Popped out for a second. Yeah, it's fine.
Okay. So students, when they finish architecture school, once they're done, if they focused a lot on computational design and these more abstract shapes, I noticed that they tend to build up their own companies, because it happens all the time. Some succeed, some don't, but they always try kind of making their own imprint, their own thing.
Yeah.
Why do you think is that? Is it because of the the need of these kind of students in Sweden is pretty low, or is it something else?
I think definitely the need for those kind of students in Sweden is pretty low, but also, I mean, a lot of computational projects. If you're making a lot of those, you're gonna build incrementally build. As more as you delve deeper into this subject, right, you're gonna build an incrementally more strange portfolio. But, at least in Sweden standards compared.
Yeah, I think it's global.
Yeah,
I think that one is global. Strange is a global thing when it comes down to parametrics.
And those, Sweden has a long history of not wanting to, try new things in the area of architecture, and I think abroad you might have I don't know about the situation abroad as much, but I mean it's also, I think definitely if you don't have any conventional projects in your portfolio. I studied, for example, since I got my bachelor's degree, I didn't study any conventional architectural course. Really, I just did computational stuff and things like that. So I've been to work interviews, where they said, "Do you have any normal projects that you might, throw in?" Because I really want to show this portfolio to him or her, and I'd like there to be some conventional projects. I think these are really interesting, but there should be some conventional projects as well, perhaps. I've actually heard that at some interviews, and I have a few conventional projects, but what I find interesting is the computational aspects, and that sort of shows, I think, in the work I'm doing in Polymorph as well with Johanna. We have a way of working together where she is very proficient in the material realm. She knows a lot about craft. She knows how. She's basically the reality expert in Polymorph. And I am leaning quite heavily on the computational side, doing a lot of the different parametric tools and parametric, doing all of the digital sort of pipeline and the parametric tools for the product. And I think it's a nice way of working together, having these two different, forces that come into play together.
Yeah, this hits home really hard. Like me and my wife, absolutely same situation. If someone asked me to show, a decent, normal portfolio, I would be just like, I don't know, man. I did like 2 projects in my life, 1.5 projects maybe in my life. So while she is the expert, right, in reality, right, and myself, I'm more of a, let's call it an academic. Let's give it a name. Let's call it an academic, right? So someone who's, we can make a script out of that.
Yeah.
We can make a script for that. How will you make it manufacturable in a cheap way so that the client is happy? Well, I don't know, but I can make a script out of that for sure.
Yeah. I just spent a weekend actually automating our G-code generation sort of process. Because it has involved several, manual steps before. But these past 2 days, I've just sort of automated that into a more clean process.
Well, actually, I want you to. We will be talking about that. You are working in Houdini, right?
We're working both in Houdini and Grasshopper.
Okay.
Mostly.
So I will ask about that, and I will ask you to show something, some part of the workflow that is not under, that's not hidden. That shouldn't be hidden from the public. But that's in just a bit. And yeah, the fact itself that kind of this digital design, or not digital, computational design, it's very scalable, right? And you can scale it to a product as well as you can scale it to an urban context, to a city, right? Almost the same approach can be applied to both, which enables the students, once they leave the university, to, well, you can't immediately go and do a city, right? You don't have the investment to do it. You need a large investor to do a city, but you can do smaller things, right? And once you kind of build it up, then maybe at some point you will do a computational city out of clay.
Sorry.
No, go ahead.
We're really, standing on two legs in that way. We're having both this design side, where we're doing, design objects, and we also have this architectural side and research side. So we're using the computational, using parametric tools in both of these.
That's super.
It's a good example of that.
Yeah, that's really great. I mean, not everyone can be this happy. So usually you do 90% or 95% of the stuff that is, let's say, budget oriented. Let's say it like that, and then last 5% you sometimes sprinkle it in, right? Sometimes sprinkle in some digital design. So the fact that you're doing research, in the university that is architecture related, as well as doing product design, is super. You get to constantly polish the skills, and kind of bring your level of game up with every iteration.
I can really feel these different aspects sort of help each other out as well. And I really don't like to do too much of one single thing. So I feel very lucky in that way, that I have this opportunity to sort of work on different projects, different scales.
And you are you're working with Grasshopper. You're working with Houdini. What else? Do you use anything else? Do you code?
Yeah, I mean, Houdini has quite a coding and scripting is very easily implemented into Houdini. It's easy implemented into Grasshopper as well, in a way. But Houdini is really, it's really easy to sort of just type little snippets of code that can help you along the chain of the node chain. I'll show you something later that
the batteries. Actually, maybe just share the screen. Just show me Houdini, because while you're doing that, because I opened Houdini once, and then in 5 minutes I closed it and then installed it, because it was wait. Why do I need to write something here? Oh, fuck off. No. Back to Grasshopper with me.
It's a little bit different than from Grasshopper, just the how you cognitively sort of approach modeling, both in the different softwares.
Okay. So just
there are some similarities as well.
You can show whatever you want, and any kind of stuff. Later on, we'll jump to your website. Like during this whole talk, I will be showing snippets of your website next to our two talking heads, but now we will be able to, after the Houdini part, we'll be able to kind of hear your narrative over the kind of projects and what you're up, what you're doing.
I should send because I'm sitting on Johanna's computer right now. I should send myself some STL files later.
Okay.
Just to show some things and of some of the workflow.
Mm-hmm. Oh, in Houdini.
Oh, in Grasshopper. Yeah. I mean, I could do something in Houdini probably.
Yeah, whichever you want. I was just honestly, I was just interested in Houdini because I just saw Junichiro Horikawa or whatever his name is coding like in live stream in Houdini, and I was like, yeah, that's some sort of a magic wizard shit right there. So I just wanted to get like an overview from someone who is actually using it for me as a kind of extremely basic user of. I don't think I could ever do anything in Houdini.
It's it's programming. You use Vex. It's a language. It's similar. It has similarities to C#.
Okay.
But it's quite hard to decode it. You can't if you program before using Visual Studio or something like that. So you can't put breakpoints in your code. So you can't sort of run through the code and pause it and see where is the mistake.
Oh, okay. So there's no debugging options.
Awesome. No, okay. I mean, no, you can't really. It's not very easy to debug.
Okay, got it. Well, that's kind of shitty. That's something that honestly with Grasshopper it's kind of similar. It's only that in Grasshopper you don't even see code. In the nodes you don't see code. It's either node is red or node is orange, and if node is red you click on the balloon and it kind of explains.
Yeah, I think decoding in visual programming, but decoding in a network of nodes is sometimes harder, definitely, because you can't really see, as you said.
Yeah, index out of range, man. Yeah. Index out of range. Okay, sure, thanks. So there we go. So now we jumped into Houdini. And you're having a drink, so I will not ask you any questions now, and I'll just kind of fill in the gap with talking about nothing. Okay, I think you finished. So Houdini, tell me about it.
So one of the biggest differences between Houdini and Grasshopper is that Houdini, I've heard, is able to use all of your processing cores. Of the cores of your processor, while Grasshopper has a hard time of doing that. Basically,
does Houdini? Does Houdini also use graphics card? The dedicated graphics card, or not?
It probably does.
Okay,
it's very powerful, but I wouldn't. Don't quote me on that.
Okay.
I don't know. Basically, it's very, but it's very. You can handle a lot of complex geometry, and you can handle a lot of particle systems with a lot of particles, many times more than you could in Grasshopper, because it was developed for the video game video game industry and the the special
movie
effects.
industry. Yeah,
exactly. So a lot of those, very processes, digital processes that are quite heavy on your computer. It handles quite fine. It's at least compared to Grasshopper.
Yeah, I mean, Grasshopper is super slow. When it comes down to computational power, it's really weak. Like in terms of speed, they started adding little by little these nodes that do use hyper-threading and multiple cores, I believe. So they have begun using those nodes, adding hyper-threading to those nodes, but it's definitely not every node, and it's still, even with that, it's freaking, like, it's so weak. if you add loops through C#, so if you, in Grasshopper, if you code with C# and you loop information there instead of using Anemone, then it's better.
Right.
You know, it's pretty fast, but then you get bottlenecked by visualizing it, by showing it on the screen. Because if you have, let's say, 1 million polygons, you're done. It's not gonna move. You will have like frame rate of 0.5. You know, if you try to move that stuff around. While in Houdini, at least from what I've seen on the internet, 1 million vertices or 1 million polygons is, yeah, sure, whatever.
Yeah, definitely. Yeah, we have a lot of models with quite, a lot of polygons, and it's been working quite fine until you import it into Rhino, into Grasshopper to do something with it there. Yeah.
You need to reduce mesh. Okay, show me cool stuff.
Houdini is very good at doing, organic stuff. So liquids, smoke, things that grow, explosions, and those are all, things coming from that you can make with particle systems, or that build on that sort of that you can use particle systems to simulate. But there's also it's pretty easy to use nodes. Loops. Loops is very easily implemented into your sort of workflow, many times more than it would be in Grasshopper, where you have Anemone to make loops. Here, loops are a really natural part of of everything. Yeah.
That's super nice.
So if I should make in using Grasshopper today, so there might be some Grasshopper. I'm trying to make some Grasshopper nodes in Houdini. But if I would just, for example, to make a simple plane like this, and just plug in a mountain, I would get something out of just 2 nodes that would have taken a lot more to do in Grasshopper, right?
So that mountain node that you just used, is it native to Houdini, or did you kind of first code it and then? Oh, okay.
It's native to Houdini. It's a noise basically. It's just a noise displacement of points. It's nothing fancy at all. But you can even have fractal noise in there if you have a high enough resolution of your mesh. Obviously, it's pretty easy to make something quite something like this very fast, just out of 2 nodes.
And Grasshopper doesn't even have noise. You need to download a plugin for that. It's the name of the game of Grasshopper.
Yeah, you have the noise with the graph, right? You can have.
Can you?
There's a Perlin graph, the graph mapper. But that's
right. Yeah. Yeah, you can, but that's one-dimensional.
Yeah, you don't have 3D or 2D noise. And here, you definitely have that.
I forgot about the graph mapper. Okay, cool. And you still have a few things there, I see.
Yeah, so Houdini works with, you can use polygons. You can use, this is just a circle. This is a simple circle node. It works with polygons. You can have NURBS. You can jump between these quite easily. And this is just a definition that I did yesterday. I'm just going to go through it maybe.
Okay.
You can see what we've sort of what kind of interesting things that we find. So, in Houdini, you make nodes that goes downwards instead of from left to right. That's a big difference from Grasshopper as well. But I find it kind of interesting that that's just how you plug in the nodes, right? Just on the top and the bottom. So that sort of does it so
oh my god, man.
Vertical node structure instead of this horizontal one.
Okay, that would I would need to get used to that stuff.
Yeah.
Holy
Yeah.
shit! And it's
Um,
not even. It doesn't really make sense as well.
Going from top to bottom.
Yeah, in all screens that are we are all using horizontal screens, right?
Mm-hmm. Yeah, I mean, this is quite small as well. I'm just using this laptop right now, and this is a really small portion of the screen. In Grasshopper, you have half the screen at least.
Yeah, that's true.
And you could move these around, but you really want to have all of these
Like
patterns.
settings and options, right?
Yeah.
Okay, so what did you cook out here?
So what I did in the end is this sort of, let's see, it's not. Well, I was building. I was doing this fractal sort of curve that I wanted to extrude, and maybe we can try that. We can try to sort of twist it around and extrude it in a way. We're gonna make something maybe polymorph out of this curve that we made. We have an idea for something that we want to make, but haven't really decided yet what it's going to be. So it's a project in the work in progress.
Okay, that's one approach. First do it and then figure out what you're going to use it for.
Yeah.
How do you do fractals here? Is there a node?
In this case, it's more manual work. So start out with this circle, and I just take a portion of it, take a quarter of it, and it's segmented into these line segments of equal size, and I convert it here, just convert it into a NURBS curve from a polygon curve. So here we have a polygon curve, and I convert it into a NURBS curve, and then I wrote this script. This is just a way of, as I said, adding little snippets of code into your Houdini workflow. So this is just, a tiny snippet of code that does something. And then you jump on to the next node, basically. This is just moves point outwards. A 50% chance of moving points in a direction perpendicular to this.
And it's always a locked position, right?
It is.
Like it's a locked
they
offset.
Are moving similar distance, right? Out here, and it's a NURBS curve, so this point is not going to weigh as much as these four are, as they're next to each other, basically. So, and then I just mirror it again. So I get this symmetrical shape. And what I do then is I just resample it. So this is your, divide curve in Grasshopper, very much, or not divide. Yeah, I mean divide curve followed by a
polyline tool.
Yeah, polyline tool. Yeah, exactly. And okay, so Grasshopper works with primitives, and a primitive is a polygon, basically. And here, if I I have one primitive, so this shape is one polygon now. It doesn't have a surface, but it's just a line that goes around. And I explode it into 32 polygons, so exploding these segments, basically. There's 32 primitives. And then I create this node, which is a for each node.
So for each line, you will apply the same pattern, right?
Yeah. So there are different for each nodes in Houdini. There are for each point, for each number, for each named primitive, for each connected piece, for each primitive, which is what I've used here. So I have one primitive here, then explode it up into 32 primitives, basically one for each little line segment.
Mm-hmm.
And then I do stuff with each of these line segments, basically in a loop here. And what I do is I do the same thing as I did up here. I take some points, I divide this little segment up into smaller segments and move them in or out, basically. So you can see here, it's a 50% process of them moving, right?
Okay.
So
yeah.
So I do that.
Smart 3D asset store.
Yeah.
Okay.
I don't know what that was. So I have a 50% chance of moving the points in and out, basically.
And 1% chance of opening a store.
It's a 1% chance. Very unlucky. So this happens.
Mm-hmm.
Basically, now we're sort of leaving the symmetry a little bit, because now we have done this thing to all of the segments.
Mm-hmm.
So we're leaving the symmetry a little bit. It's still there, vaguely, but join all the primitives up together into one primitive. Do the same thing again, exploit. Now I have 96 primitives. Do it again.
Mm-hmm. Mm-hmm. So it's like this is the third iteration, right?
Exactly.
Uh-huh.
Yeah. So exactly. So perhaps not fractal, but some type of sort of recursion.
Fractal-esque.
Yeah. So and end up with this curve that I can do something interesting with.
So you extrude it.
Exactly. This is, as I said, this is Johanna's computer, and the bend node works a little bit different. She has a different version of Houdini than I have. Let's see if we can sort of do what I did previously. Just need to change this, perhaps. I don't know.
Isn't up vector z like the third one?
Yeah. Here is the capture origin. All right. I think I'm just trying to understand why.
Oh, this is very familiar. While you're doing that, I'll just kind of talk. In Grasshopper, this always happens to me for some reason. Every time when I kind of give a tutorial for the students and I prepare some material beforehand, it is just a rule that there is going to be an update right before the lecture, and one of the nodes will stop behaving properly, and then I will need to kind of sit there just rant about how they changed it again and now I can't show it to you. Wait, let me reset. So it's definitely I don't know, it transfers through all of these kind of programs.
Yeah, I have something.
You have that. Okay.
That I can do now, at least. I just did another bend node. I don't know what happened to that one, but this is something that we did.
Okay.
It's very easy to do. Strange geometry like this in Houdini, just to twist it around. And as you can see, it's very, very fast.
Yep.
At doing it.
Is there a way of displaying how many vertices you're working with right now?
Currently, we're working with 57,000 vertices.
57,000.
Polygons or primitives are 14,000 polygons. You can try to increase it in a
I'm just interested to see when will it break.
So
and by the way, what kind of laptop are you running it on?
I'm running it on a Razer Blade.
16 gigs of RAM?
Yeah.
Okay. But it is a laptop, okay.
It is, yeah. You can see how many polygons we can crank this up to, and you just notice when I will leave the discussion of my computer frozen.
That's fine. I'll call you again. Holy shit!
So now I just mirrored these two sort of shapes, fractal shapes together.
Is it possible to Boolean union them together?
It is. But what we like to do is we could try that. But what we'd like to do is to turn this intersecting model into a voxel object. So it's made out of voxels. This is quite a neat little trick that's great for Houdini. Just convert this polygon model now. We have 500,000 polygons currently.
Yeah.
So we're gonna turn this 500,000 polygon into a
like a voxel field.
Yeah.
Okay. That is actually how I merge really complex meshes as well, but in Grasshopper. If Boolean union is out of the question, then I straight up, oh my god, you need more resolution, man.
So here the voxels are huge.
Yeah.
We can decrease their size. This is a heavy operation.
Yeah, I would assume so, but this is like so much faster than what it is in Grasshopper.
I'm gonna go a little bit lower. Let's see. Okay, so we have something. At least we could perhaps go a little bit lower. But, and then I'll have it now as a voxel sort of model. I'm gonna convert it back into polygons. Right? And there we go. So now they're one single model, right? They're not intersecting anymore.
Oh, wait, stop rotating for a bit. So it does subdivide it at some point.
It does subdivide it because it tries to sort of remap the voxel size into a polygon size or something like that.
Okay.
So if I have bigger voxels, it's gonna be.
So it's going to slightly
polygons.
smooth it. Yeah. Okay.
So yeah.
I think you use 0.007 or something like that. But yeah, that's cool.
Yeah.
Do you ever get mistakes that it's not a closed mesh anymore, or that you have a lot of shitty faces or something like that, like a null?
Yeah. Actually, if you have an opening in your mesh like this, so you notice here that we close it off.
Yeah.
But if you have an opening in your mesh and you try to turn it into a voxel geometry, you're just gonna get this sort of.
Oh, beautiful.
Yeah. But
try 3D printing that.
It just turns into, I don't know. I didn't even try to convert this back into polygons actually. So, something like this. So.
Yeah, actually, this is what. Are you familiar with Blender sculpting? Like sculpting in Blender? This is what you get when you break the sculpt in Blender and when you create an opening in the sculpt. Because Blender sculpting also works with it's dynamically remeshing, right? So it's dynamically remeshing using voxels. If you create a hole in your sculpt accidentally, you will get exactly that effect. So I think this is where if you have infinitely thin geometry, it just over all programs it does that shit.
Yeah.
But if it's closed, it works always.
If it's closed, it works. It works pretty much all the time. Yeah.
Nice.
It's a nice trick just to make things 3D printable.
Yeah, absolutely.
Because you don't want to have intersecting geometry, but it can be quite heavy, as I said, on your computer.
Yeah, but holy shit, man, that was 2 nodes. That was literally 2 nodes that you used.
2 nodes, just converting into. I can see people just using Houdini for that, honestly.
Yeah. Same. I'm not thinking of downloading Houdini. Is it free?
It's free. The
like education license?
The
or something
education.
like that?
I mean, if the apprentice version is free,
Okay.
and basically you can only render at a certain resolution, and you get a watermark if you render stuff out.
Okay.
Modeling is fine.
Okay, that's. Oh yeah, because Houdini is used for effects, right? So rendering is a big part of it.
Exactly.
Yeah, it makes sense that they would do it. So now you're trying to Boolean them.
Yeah, and of course.
And it literally works. Well, kind of.
There are some artifacts in there.
Uh-huh. But that's something that you can delete manually.
I don't know if this works.
By the way, the house actually, seems to do the trick. The topology is complete garbage now in the caps, but other than topology, it seems to do the trick. Even seeing something like this, mesh booleans actually working is a refresher. That's definitely refreshing. In Rhino, it's what, 10%? That's going to work.
Yeah. I mean, the booleans are the best I've ever used in any software.
Okay. Blender has really, really good ones as well. But that's, Blender also, like scripting in Blender is horrible. And then the reason why I'm kind of clumping Houdini and Blender into one boat, like for the second time now, is because Blender is as fast as Houdini when it comes down to booleans and voxelizing stuff, right? So I think they probably share a few, how do you call it? Scripts, let's say like the framework. They share a little bit of the framework in between each other, but scripting in Blender is you just do it for manual stuff.
What programming language are you scripting in Blender?
Python, I think.
Python.
Yeah, I think it's Python. Don't quote me on that. Don't quote me. I don't know, but from the scripts that I've seen, it was Python. So I think it's Python, but maybe you can do a few languages. Maybe you can port languages.
Yeah.
Okay. Do you do anything else with it, or is this the final product that you would start printing?
We would take this into Grasshopper, where we would generate the G code for it.
Okay. And you can't put it in Grasshopper now because you need to switch computers, right?
I can put it in Grasshopper, yeah.
Oh, you can?
Because what we've been working with is sort of this non-planar printing, 3D printing.
Holy shit, man.
Where you have an angled top plane, right, of your print. So you want to sort of increase the layer height more in one end of the print than you do in another one.
Is that not a government secret on how to do it? Are you? Okay, so you're not going to show us that.
I mean, it's something that we do in Grasshopper.
Okay.
So if I were to Boolean this thing with an angled plane, let's see.
By the way, while you're doing it, how's hand modeling in Houdini? Is it possible?
Horrible, I think.
Horrible. Okay, got it.
I haven't tried it.
Okay, fair enough.
I haven't seen anyone do it.
Okay. But it is possible, if you just need to tweak, a few.
Yeah, I mean, you
things.
can move a point or something like that. Yeah,
okay.
It's definitely possible. That's how I've seen people using it.
Okay.
Before actually. So if I were, if we were to print something like this.
All right. If you were printing that,
exactly,
the top would be shitty.
Yeah, exactly. But you want to have the same, same amount of layers all the way, not stop here and just continue here, but you want to increase the layer height in this side to the right compared to on the left side.
Okay.
Yeah, that's what we use, Grasshopper for to make this sort of slicing
Hmm.
possible. And we
Are
use
there?
Silkworm for that.
Oh, you use Silkworm. Okay.
Mm.
Are there any non-secret things that you can show in Grasshopper?
I mean, we can just I can try to slice this up and see how that works. Let's
Okay.
take this one.
Sure.
So
Yeah, just a regular one.
yeah, let's do it. So Houdini is really good at exporting different kinds of files.
Mm-hmm.
You can choose from a lot of different ones. Mostly I export STL or OBJs. Let's just export something to the...
You know how I treat STLs and OBJs? If I know for a fact that it's just the geometry that I want, without anything, without any vertex information, without any material information, without nothing, just bare geometry, without any smoothing information as well. Which vertices are actually smooth and which vertices are not, then it's STL. If I need at least one of those things, then it's immediately OBJ.
Yeah.
Right? Because STL, for instance, for rendering purposes, you lose so much information that it's really rough trying to get it back. In your case, every vertex is a smooth vertex, right? So, like, you don't have any sharp corners. Oh wait, you do. At the top and in the bottom of this shape, you have sharp
there
corners.
There might be some, very sharp things like this, which doesn't look very good. That might have to be solved, in Houdini rather than in Grasshopper in some way.
Is that solved through? No, wait. Through proximity checking within the
figure that out yet, but we'll see. I mean, it's solvable by decreasing the voxel size quite a bit.
Yeah.
So that one voxel sort of fits here. This very sharp, edge. But that's a very heavy, thing to do.
I mean, you say a heavy thing to do, but I noticed you working with 500,000 polygon mesh in Houdini in real time.
Yeah.
So
I increased the voxel size a little bit just to make the processing Grasshopper easier.
Also, it doesn't really matter for clay printing because you have the restriction of the diameter of the nozzle either way, right? So
this computer. Yeah. All right. So, what was it that you said with the nozzle?
Like it doesn't really matter if you have a, let's say, lower resolution mesh than the perfect one, because your nozzle size will be the limiting factor.
Yeah.
While printing.
If you have a big nozzle, you want to have, you can have a low resolution mesh. Basically. If you have a small nozzle, you can have quite a high resolution mesh. Yeah. We've done some experiments to see the correlation between mesh subdivision level and nozzle size. Just, at one point the nozzle really fails at representing the intricacy of the mesh.
Yeah. It's just everything gets filleted by the radius of the nozzle. That's how I always think about it. All of the lines are going to have that turning radius, that fillet. Same thing for CNC milling as well. Holy shit, man! That's a noodle fiesta right there.
That's
have you heard of clusters?
As I said, I did this the last couple of days, so I just still have to go through this and reorganize it. I don't understand why it's not working on this computer, but Anyway.
That's fine. If you need to switch to another computer, we can.
Yeah, sure. I can switch to my other computer. I can show. All right, so here we go.
Okay, we're back, and this time with a cat and one more laptop and one more webcam.
Okay.
Okay. Let's see again.
So what I did, okay, I'm gonna show something with this thing.
Okay.
So this is a brick basically
Mm-hmm.
that we did. So as you can see, it's angled differently at the bottom and at the top. It's not a straight cut at the top. Let's just scale this up a little bit. So this is basically our, and some artifacts here at the bottom, just to remove them. This is basically our bespoke slicer that we have. So
is the mesh still closed though? You just deleted
the mesh is not
parts.
Closed. Yeah.
Oh,
so
okay.
That's the thing that this slicer does as well. It works with closed and not closed meshes.
You should sell the idea to Cura. But it does only work with spiralized, like spiralized contours, right?
It doesn't spiralize. This is the seam script.
Oh, it's like does one contour moves up, does the other moves up?
Yeah, exactly. Stupid in that way. I'm still working on
whatever
the spiralize, which would have been awesome as well, of course, but it's harder. So I have remove small curves, because sometimes if you slice things, there might be some little curves that you don't want to print that are tiny. Just equalize segments, which is basically create all of the curves that you slice, the G code basically, to have the same amount of segments related to their length. So that if you have a line that has a lot of segments and it's really short, the printer is going to go super slowly to print all of those segments. But if you have fewer segments, it's going to be quicker. So equalizing the segments to have the same segment size across the whole model, if that makes any sense.
Is it because of the acceleration?
I think it is. I don't know, because
printers have that acceleration thing, like acceleration override. Yeah. And I noticed that it happens with my old Chinese knockoff printer, because it's not rigid, right? So the acceleration is way down. And when I have a lot of these small segments, it just crawls to a halt almost, right? It becomes super slow.
It has to do with that, yeah. Or it feels like it has to do, or something that a segment has to take this long to print. So if you have a lot of segments, it's just more segments. Thus takes longer.
Check out acceleration and jerk. Those two settings. Those could be helpful.
I'm gonna definitely check that out. So we're printing in clay. 0.4 is quite a low layer height. This is millimeters.
Kind of low, huh?
We could have like a layer height of 2 millimeters or something. Let's just crank it up to 5 so that you can see kind of thing. This is the initial layer height. Just remove layers at the bottom of the Z hop in between layers, 4 millimeters. Speed, so nothing fancy.
Okay. And now it's doing the thing?
It's doing the thing. There we go.
And that is literally 4 layers. But it's doing the thing really fast.
The model is really small, so the layer height is...
Yeah, it's going to be like a 5 centimeter model, right?
Yeah, something like that.
Okay.
If I haven't miscalculated somewhere, but yeah.
Okay, so then you get a bunch of contours that are actually following along the curvature.
Exactly. And as you can see, the model in the space is angled, it's rotated differently, and it's not on the ground. So this slicer takes care of all of that and puts it in the right position, because this is the out-of-home position of the printer. And I'm sort of facing the printer right now, so it's kind of placed.
Oh, so it even puts it in the correct positioning on the print bed.
And we want to have the higher position to the right, because if we want to make a change clay or an out-of-home, we don't want the arm to sort of move over the printer and just knock it over, move over the printed object. So it has to be higher in this end, because the out-of-home is here, and it will move to there. So
that's super cool.
And we also, so I will generate the G code for this. It's just the data down.
How do you generate G code? Do you use Silkworm or something like that?
Silkworm, yeah.
Okay.
So.
And does it have a preset for, or do you need to actually,
clay?
Yeah, for clay.
It has. We're just plugging in INI settings here.
Okay.
So this is the INI settings of the printer. It's just end and start G code, basically, I think.
Okay.
Sort of, rip wrap, G code flavor and stuff.
Yeah. Oh, so it's running rep wrap.
I don't know where that file is, but I think it is. Yeah.
Okay.
So. Yeah. So the flow value is different here on the left and on the right, because the layer height is higher here, so it has to. It has to change.
Push out more. Huh?
It has to be proportional. Yeah. And there we go. Just use Droid for saving the G code. Let's save it. Put it on the printer.
Brick.
So many bricks.
So many bricks.
Yeah.
Okay, so you do some stuff, you slice it up, and then you print it, huh?
Yeah.
Do you have a? You said you have a video of.
I can probably send you that link or something, and you can just.
Okay.
Because I'm not gonna find it now. It's somewhere on Vimeo. I don't know
somewhere deep on the internet. That's fine. I will put a video of it as we talk right now. I'm cutting off again.
Sorry.
Am I cutting off again?
Yeah, a little bit. It's fine. It's fine.
Okay.
It's fine.
I will put a video as we are talking, like further right now. Just somewhere on the screen, people will see it. Just printing in clay and in general is pretty damn cool thing. And you're using Luton for that. And how much is a clay printer these days?
We actually were super lucky and managed to buy a second-hand Luton printer. So we paid about 60% the price. I think a new one is about 70 or 80. 7,000 or 8,000 euros.
Okay. 70 or 80. I'm just raising the eyebrows. What do you mean, man?
70,000 euros.
You could get a used Tesla for that, man.
I mean, it's more expensive, obviously, than a normal 3D printer, but
yeah, but it's in the same ballpark as a EVA. Have you heard of EVA?
Yeah, the arm, robotic arm.
Yeah, the robot arm. So it's the same price range as the robot arm. Of course, it's not the robots from ABB or anything like that, or not KUKA robots, but having Luton and EVA being in the same price range, I think is great. That just shows that the technology, for manufacturing these kind of things, that you and me and all of us are trying to design. The technology is becoming available for small businesses.
Yeah.
I wouldn't say that it's still for home use. I mean, it's come on, it's 7,000 euros, right? So it's for home use, maybe it's a little bit too steep, but for like small business owners. Super, it's great.
For home use, it still comes with a few other things. You need a separator for the clay, so you don't clog up your pipes at home with the clay. And you need, if you want to fire the stuff, you still need an oven.
All right, you are glazing that stuff as well.
We're glazing, glazing some of the things that we print. And
does your video? Does your Vimeo video show the glazing process as well or not?
No, it's just some printing. Yeah.
Okay, that's fine. But people will see the glazed stuff from the Polymorph website, and also
probably,
pictures from the exhibition.
Stuff on the website.
Yeah. What do you sell? What do you? How can people get your stuff, and what kind of stuff can people get from you?
We're about to open as I said, we have the architecture side, we have the research leg, and we have the design object leg as well in the company. So we're about to open up our own web shop. Previously this summer, we decided that we should code our web shop ourselves, which was a huge endeavor to do. We didn't know how long it would take to actually do it, but now we're almost finished. We're pretty much finished. So just it's the web shop. Everything is up. We have products in the shop, but it's not possible to buy anything.
Is it possible to access it? For like a normal average person?
Yeah, it should be up there.
Okay, but that's good. That's what kind of. What's nice to show, that you don't really need to push out plastic from that hole. You can also push out clay. And in case of MIT, you can push out glass. Have you seen that they are printing MIT glass 3D printing? Have you seen these projects?
Yeah, I've seen it.
Yeah, that's pretty sweet.
It's a few years now, right?
Oh yeah. It's like 5 now, I think. We're getting old. But they keep increasing it. Right now they're doing like these columns from them, so it's not bolts anymore, but rather it's columns, I guess. Which is pretty cool.
Wow.
Having stuff like that.
So you have just printing bricks, sort of. It's like
it's the same thing as clay printing, only on steroids. It's like an.
Is it just cylinders you're printing?
Not really. I mean, these are not. Aren't these cylinders? I think these are kind of wavy cylinders. So similar to what you would see here, right? Yeah. This kind of stuff only it's not tapering; it's just extruded, right? So it doesn't have a bend or. I assume printing in glass is even, rougher than printing with clay. So okay, what's the address? Where should I go to see your stuff?
It's actually It's actually not on our custom domain yet, but you should go to Polymorph. There you go. I sent it to you earlier. It's like polymorph.azure.net. Yeah.
Is it Azure or Azure?
Azure.
Azure.
Yeah.
Okay. Oh, there's you. Yeah. There's Johanna. And there are your things.
Exactly.
I don't know how to call them structures. Let's call them structures. Yeah. Sculptures. Structures.
The website is still in development, so things are going to change definitely.
Yeah, but I love the color theme. the background colors. Oh, and here you have the shop, right?
Yeah.
Where's your stuff? There's no stuff here.
Click on it. Click on the name.
Okay, fair enough. It needs to immediately show me the stuff, or else I just click out. That's business 101.
That's good feedback.
as little amount of clicks as possible to get to the necessary stuff. So these are not euros. That's an important statement to be made.
You can change to euros also. That's a feature that we have.
There we go. So these are euros. Okay. So all of these are 3D printed and then hand glazed and fired in an oven, right?
Fired twice. Yeah.
Fired twice? Why do you fire it twice?
You have to fire a bisque firing, a sort of a lower temperature, still very high, but a lower temperature firing, just to make them more durable while you're handling them with a glaze. So you're firing them once before you glaze them and then once after you glaze them. You can go straight up to sort of max temperature if you like. But,
This looks beautiful. Like the layers and the glazing with the layers looks real nice. How long does it take to do one?
It really depends on your nozzle size.
I'm not talking about printing. I'm just talking about from start to finish. And let's say you're doing, you're firing, I don't know how many you're firing at a time. 10 of these?
We could fire probably more than that. I don't know exactly how many. Yeah.
Mm-hmm. But let's say if you were firing 5 of these, if you were to kind of divide quickly, do quick math and divide up, how long does it take to do one, except for the design, of course?
There is a lot of wait time in different stages of the process. So once you've fired it, you need to wait for about a day, 24 hours before you can fire it, because it needs to dry up a little bit. And I mean, there are some waiting that you have to do. So it's hard to say exactly how long it takes. If you really stress, just try to do it as quickly as possible. I mean, the oven takes 3 days to cool down, so.
Jesus Christ, man.
Yeah, there is some waiting.
Wait, but
maybe you could do it in, if you have to glaze it a week, maybe, if you really try to push it.
So a week to make, let's say, 10.
Yeah, you can make more than 10.
More than 10. Okay.
Yeah.
Okay. But that's good.
Yeah,
I just wanted to.
Yeah, depends on your oven size and definitely, but it's not 10 days of active work. I mean,
yeah, because there's a lot of downtime of just waiting while you can kind of work on other stuff. Yeah. But I just wanted to kind of hear a time frame of, let's say you get a custom request, right? Or something like that. And how long would be the process of kind of making something custom, something that you don't have on hand, but from start to finish.
Yeah. These are made to order. So
all of these are made to order.
We don't have a stock of products. We just have things that we make upon order. So we have it's going to be a few weeks until we can finish everything and send it away.
Yeah, and ship it, right?
Yeah.
What about so here all of your stuff that you're showing now is symmetrical, like on one axis, around one axis, right? Yeah. And stuff that you showed in the, I can actually go to main side. Yeah, stuff here. It is symmetrical for sure, but it is it's more fractal, less symmetrical. Have you? Are you considering like doing another batch of the pots, which would be more crazy, less conventional?
This is the first collection of products that we're releasing, but we're gonna release more in the future. That'll be more crazier.
Crazier.
Yeah.
That's super cool. And here you have your the weave and so on. Again, during the video, I will be showing this, to everyone and just kind of going through this. But it all started with this project, right?
It did, yeah.
I remember you guys messing around with it and checking out, how it can work and how you can kind of arrange these clay 3D prints into one structure. That was super nice.
Yeah, that was, I think, the most challenging part about it was how to slice that thing up into printable bricks.
Yeah, I mean it came out really nicely. Like the tests and so on, they came out really nicely, and it's nice to see that you're kind of pursuing the same approach, I guess, the same procedure in terms of aesthetics. Because while there are people who are working with like fractal design and so on, in the industry, there's not a lot of physical stuff. Physical stuff that comes from fractal design. Because to do actual physical stuff that comes from fractal design, you need to have some sort of a computation-based, like digitally driven manufacturing technique, manufacturing method. CNC milling, perhaps laser cutting, but 3D printing definitely being one of those. And there's not a lot still, even though Lund is producing quite a lot of clay 3D printers. By 3D printers, I mean the profession, not the machine. But there is definitely, I would still call this a niche within the industry, right? Within the industry of design, which is, it's nice to see you guys filling it in.
Cool.
All right, man. It's been great. I think this whole thing was a success. How do you think?
It was super fun.
It's fun.
A bit confusing, perhaps. I am a little bit tend to have that effect.
You do tend to have an effect of being confusing, but that's fine. I accommodate it and I encourage it. I like when both my tutorials and my podcasts and all of the material that I do is slightly awkward. Just a tiny bit. It has that smidge of pauses that are 1 second too long. It's not like 2 seconds too long, but it's just 1 second. There's discomfort there. I love that.
That's how we grow.
Yeah, exactly. We can now just sit in silence and just drink. Just have a drink, man. Perfect. Yeah. Drink it all. Okay. Enough of awkwardness. I thank you.
Thank you.
And I bid you adieu. Okay. See you, man.
See you.